So in this video we look at data types and records. This is section 10.1 of the CIE 9618 computer science course. So when we're creating variables in programs, we need to define what data type they have. Some programming languages are statically typed, which means you declare the data type before you start using the variable, and that applies to CIE exam pseudocode. Languages like Python are dynamically typed, so they allocate the data type automatically themselves. You don't have to do it yourself in the program. But a data type tells the computer what kind of value a variable can hold, how much memory to reserve for it, and which operations are valid. And choosing the wrong type is one of the most common causes of logic errors. So when you declare a variable, you give it an identifier, a name, and you give it a data type. And then a certain amount of memory is reserved for that variable, depending on the kind of data that you said you were going to store in it. So for example, age is an integer and price is a real number, and those two things may well have different amounts of storage allocated to them. Grade, being a single character, would need a lot less storage than a string. True or false can be stored in a small amount of space. And then there are things like dates and times and lots of different kinds of data types that all need various amounts of storage and can be processed in different ways. For example, in most languages, adding two characters together doesn't really make sense, so it wouldn't allow the operation. But adding two numbers together is fine. So there are 6 primitive data types that we look at here. We've got integer, which is for whole numbers, positive or negative. Real, which are numbers with a fractional part, for example 3.14 and minus 0.5. Single characters, called char, and they can be characters or symbols, but only one. String, that could have 0 or more characters in it. Boolean, which are only ever true or false. And calendar dates in a date field. We also have arrays and files. An array is a data type that can store a fixed number of elements of the same data type, and they can be accessed by index. We look at arrays much more in the next video. And files represent external files for permanent storage of data that last beyond the program execution. And you'll be able to open files, read files, and close files. We also have records, and records group related data under a single identifier. So in a single variable, you can only hold one value of one type. But in real situations, you often have several pieces of related data that you want to store and treat as one thing. And a record structure solves that problem. It bundles multiple name fields together with its own data type under one identifier. So in this case, we have student, and student is a data type, but it's a record data type. And within that, we have student ID, name, date of birth, and grade. And they all have their own data types as well. And fields are accessed with dot notation. So if you want to refer to one particular part of the record, then you use the record data type followed by a full stop, followed by the name of the field that you want. For example, student.name would give you just the name from the record, and student.grade just the grade. So to use records in CIE pseudocode, we're going to first use the type and end type as a template wrapper, and inside we're going to declare all of the individual fields that we want. So type end type marks the start and end of the record definition. We have a name for the record, in this case student record, This is like a custom data type that you create to be used as much as you want later. We have the normal declares inside for each individual field. And remember that nothing has actually been used or allocated yet in terms of memory or data. It's purely a template, like we're just defining our own new data type that we'd want to use. Then we can actually start using it by declaring variables of the data type that we created. So here we're declaring student 1 and student 2, and both of them use this new data type we created called student record. And they're both ready to be populated with data in all the same fields as each other. So they all have a student ID, a name, a date of birth, and a grade. So to use them, assignment is completely normal. We just use the same arrow as the rest of assignment in CIE pseudocode, except that we use dot notation to indicate which particular field of the record we're talking about. And again, input output is exactly the same as normal, but you just use dot notation to indicate the field you're interested in. You can also refer to the entire record. For example, if you want to move the entire student 2 record into student 1, you can do that. So long as they're the same data type, that's absolutely no problem. So here's a little bit of a worked example. Our pseudocode program. First of all, we declare the data type we want to use, our record data type. Then we declare a student of that type, student record, inputs and values into the fields within the record, do a check, a conditional statement check on one of the fields, and then output one of the fields, or a couple of the fields actually, student.name and student1.grade. So, summary. We've got various data types we can use in our pseudocode and our programs as well, like integer, real, char, string, boolean, and so on. You need to try and pick the data type that matches the values you want to store and the operations that will be carried out on them. Then we've got records, which group related fields of different data types under a single identifier and create a new data type. So you define it once with type ntype and then declare your variables just as normal but using your new type. And then to access individual fields, you use dot notation. So the identifier, the variable name, followed by full stop, followed by the individual field name. And it works completely normally like any other variable then. Alright, that's the end of 10.1. And the next section, 10.2, we look more at arrays.